Good evening. Confirm audio and video. So time, speed, distance. We'll cover this topic probably in 6 sessions. A lot of content is there. A lot of small variations are there of same concept. In terms of formula, there's only one formula. Distance is equal to speed into time. This formula can be manipulated in 10 different ways, and we keep on reapplying this formula to generate new concepts and questions. Give me a second. I'll be back. We'll wait for more people to join. So I was telling you guys there's a lot of theory to be done in this particular topic with small variations. There are no big changes. So I was telling you we'll be taking maybe 5 or 6 sessions in total for TSD. So what is the formula that connects these three terms, these three variables? So it is written in a single manner as a simple way as Distance is equal to speed into time. I can rearrange this. I can write speed is equal to distance upon time. I can further rewrite this as time required is equal to distance upon speed. So these three formulas we use in an interchanging manner based upon what information is given, what is asked, what variables, what information is available in the question. So one is distance is equal to speed into time. One is speed is equal to distance upon time, and the last one is time is equal to distance upon speed. In general, we use two units. Basically, for speed, we say distance upon time. Distance can be in kilometers, time should be in hours. Distance could be in meters, time should be in seconds. So we use kmph, kilometer per hour, and meter per second, mps, meter per second, kmph. What is the relation between the two? What is the conversion factor between the two? 1 kilometer is worth 1000 meters, and 1 hour is worth 60 into 60 seconds. So the conversion factor between the two is, if I cancel these zeros, if I cancel this multiple of 2, 1 kilometer per hour is equal to 5 by 18 meter per second. That is the conversion factor. If you give me x kilometers per hour, I will need 5x by 18 meter per second. Reversal of this. If I give you y meter per second, you can convert 18y by 5 kilometers per hour. How to remember this? See, kilometer is a larger unit, meter is a smaller unit. So from larger to smaller, you are multiplying a number. That number is below 1. It's a decimal, 0 point something, maybe 0.4 something, 0.3 something. So you're multiplying a smaller number. When going to a smaller unit, you're multiplying a smaller number. Meter is a smaller number, kilometer is a larger number, larger unit. So you're multiplying here 18 by 5, which is more than, which is basically 3.6. You're multiplying a larger term to go to a larger unit. So write down this stuff, comment done. We'll build upon this. I'll give you 10, 15, 6 to 7 pairs, 10, 15 numbers to relate and remember. Jot this down, comment done. This is absolute basic of time, speed, distance. What is the unit? What is the formula? How are they related? Comment done. Good. Others also commented done. Now I'll give you a small chart that I want you to remember. I'll clean some of this up. See, what I'm basically trying to tell you here is when kilometer per hour is a multiple of 18, meter per second is a multiple of 5. What that means is 18 kilometer per hours is equal to 5 meters per second. 36 kilometers per hour is equal to 10 meters per second. 54 kilometers per hour is 15 meters per second. 72 kilometers per hour is 20 meters per second. 90 kilometers per hour is 25 meters per second. What is this? This is 18 into 5. So what is this? 5 into 5. It will be the same multiple on both sides. remember this chart, a pair of 6 numbers, 7 numbers. So 12 to 14 values, if you remember, it'll be very beneficial for you if you can solve questions faster. 108 is 18 into 6. So what is 5 into 6? 30. Copy this down. Let me know once you are done. Good, good. Now, some small cases could be there in which unit is slightly different. Let me give you a small example. Let us say somebody named Suresh is traveling, let us say, 1200 meters, 1200 meters in 15 minutes. The question could be convert it in kmph. The question could be convert it in meter per second. First of all, for speed to be calculated, distance should always be in the numerator, 1200, and time should always be in the denominator, 15. The problem is it is in meters. If I want kilometers, I need to divide by 1000. The time is in minutes. If I want in hours, I must divide it by 60. So standard approach, standard theory, nothing fancy. So 1200 divided by 1000, and this will cross over, this will reverse, 60 upon 15. Now go crazy, cancel everything. Three zeros are gone. This is 3 into 4, 3 into 5. So 24 upon 5 kmph. Your job is done. If you wanted that in meter per second, what you could do is it is already in meters. The numerator is already in meters. How do you convert this in seconds? 15 minutes. Every minute has 60 seconds. So when converting in seconds, you multiply it by 60. When converting in hours, you divide by 60. This is common sense. If I give you 45 minutes, how many hours is that? We divide it by 60. If I give you 45 minutes and say how many seconds is that? You multiply it by 60. While converting in seconds, you multiply by 60. While converting in hours, you divide by 60. That is common sense. So cancel everything. 0, 0 gone. 15 into 8, 8 upon 6. That is 4 by 3 meter per second. Now let me see if the conversion factor works. Let me see if it works. What is kmph? 24 by 5. To convert that in meter per second, what do I need to multiply? I need to multiply 5 by 18. Now meter per second. See, cancel, cancel. 6 into 4, 6 into 3. Yes, the formula or the ratio perfectly works. Take your time, copy this down. Converting between units. We never use miles, we never use feet or foot. If that is there in exam, they will give you conversion factor. We use kmph and meter per second throughout. So small example, how to convert meters into kilometers divided by 1000. Reversal. If somebody is traveling 2 kilometers, how many meters is that? You multiply it by 1000. Same as seconds. You want to convert in seconds, you multiply. You want to convert in hour, you divide. Here, you want to convert in meter, you multiply. You want to convert in kilometer, you divide. Very simple approach. Very good. Moving on. Now, concept of proportionality we have seen in ratio proportion. If I say A is directly proportional to B, increase in A means increase in B, decrease in A means decrease in B. We solve it through ratios A1 by A2 is equal to B1 by B2. When we say indirectly proportional, this was direct, indirect, indirect proportion. If I say A is inversely proportional or indirectly proportional, it is written as 1 upon. When you increase A, C will decrease. When you decrease A, C will increase. How do we solve it through ratios? A1 upon A2. Please observe 1 is in the numerator, so C1 will be below. There's a diagonal relation. A is above, C is below. A is below, A2 is below, C2 will be above. What is this called? Indirect relation. We have covered all of this where ratio, proportion, variation. What is a mixed proportionality? If A depends upon B and also A depends upon inverse of C, you can combine both. A depends upon B by C. A depends upon B by C. Copy this down. We have talked about this earlier. We are going to apply this understanding to speed, time, and distance. Comment done. Very good. Now, how does all of this relate with time, speed, distance? If I say somebody is traveling at a fixed speed, speed has been kept fixed. Let us say speed is 60 km/h. If the person travels for more time, the person will cover more distance because speed is fixed. If let us say a person was traveling 2 hours, the person would have traveled 120 kilometers. If the person travels for 3 hours, the person will travel more distance. If the person travels less time, learn to work with decimals, 1.5 hours, the person will travel 90 kilometers. So as compared to this, more time, as compared to this, more distance, as compared to this, lesser time, as compared to this, lesser distance. So we say when speed has been kept fixed, time is proportional to distance, or reverse, distance proportional to time. It is one and the same. Both are same. We use this kind of thought process when it is the, let us say, same car. Same car is maintaining same speed. On one day it traveled 84 kilometers. Second day it traveled, let us say, 60 kilometers. Because it is the same car, it is the same speed. The distance of ratio is equal to distance of the journey. Speed is constant, distance represents time, reverse, time represents distance. So there are three proportionalities. We are covering the first one, speed constant. Let us say some small example. There is a ant here. The distance on this side is 3 units, distance on this side is 4 units. Distance could be kilometers, could be meters, could be anything. Distance could be anything. So in this case, in this case we can say, because the distance has been given, the time, if I call it A, if I call it B, the time taken by ant to go to B, and time taken by ant to go to A from here will be in the ratio of 4/3, because ant is going to maintain same speed as the assumption. The speed will be same. So you will come across many such observations, assumptions while solving questions. What you need to keep in mind is speed is fixed, distance and time represent each other. They are directly proportional. T1 by T2 is same as D1 by D2. Write it down. I can create many examples. There is a circle. In that circle, a person is running along the diameter, and some hints will be given. When the person stops here, he is 200 meters away. When the person comes and returns, he is 300 meters away. So I can convert these meters into time. I can put them in ratio. Numerous examples can be formed. What is the idea? Speed is fixed, distance becomes time. लिखो ये चीजें, let me know you are able to keep up with this. Done. Very good. Very good. Copy all of this down. This is the first type of proportionality. Second, time has been kept fixed. Let us say you have borrowed vehicle from one of your relatives. You have that bike with you for 2 hours. Fixed, 2 hours are fixed. Today you travel, let us say at 60 kmph. How far will you go? You will travel 120 kilometers. Let us say next day you travel at 75 kmph. Time into speed is equal to distance. So do you see, as compared to this, because the speed is higher, the distance is also higher. If you, let us say, travel slower, let us say at a smaller number, let us say 35 kmph. I'm using this as a reference. As compared to this, you are driving slow. So you will travel 70 kilometers. Time into speed is equal to distance. So lower speed means lower distance. Here, they are both increasing, decreasing together. So we say speed is proportional to distance. S1 by S2 is equal to D1 by D2. This is called a proportion. You remember proportion. Hints will be given. On a particular day. Time is not given. They simply say in the same time. On a particular day, Ramesh traveled at 60 kmph. He traveled some distance will be given to you. On the next day, he wants this much distance. What speed should he maintain? Very easy stuff. Now, what is the practical application of this? See, if this is a line, it's a straight line. There is Amit here, there is, let us say, Deepak here on the opposite side, and they are traveling on the same line together. They both started at 10 a.m. and they met here. They met here. Amit and Deepak met here. Do you understand this distance that Amit has traveled and this distance that Deepak has traveled? The time is given to them is same. So speed of Amit and speed of Deepak will be in the ratio of distance of Amit and distance of Deepak. Let us say this is 100 kilometers. Let us say this is 60 kilometers. So the speed ratio of these two will be 60 by 100, 3 by 5. I do not know the actual speed. I'm not telling you कितने बजे मिले. I don't know the actual speed. I can say because उन्होंने journey साथ में शुरू किया and they meet somewhere, the speed becomes the distance, distance becomes the speed. और एक example देखते हैं. This is a race. This is the race. We have a complete session on races. Don't worry. It's a race of 100 meters. In a race, you know, all of the people start from the same point. And the race ends when they finish the journey. But in theory, what we do is, in the language, A and B start together and A beats B. A defeats B, beats B by 20 meters. This way of saying means the time given to A is same as time given to B. How? They start together and as soon as A reaches here, I measure where is B. So time of A and B is same. So the distance of A and B actually become their speeds. How much has A traveled? 100 meters. How much has B traveled? 80, which is what? 5 by 4. So it becomes their speed as well. So these are practical examples of time constant. I've given you how many examples? 2 examples. I can keep on creating 3 more examples, 2 more examples. That is not the idea. We'll have enough questions. Don't worry. I was telling you when people travel for same amount of time, the speed and distance are proportional to each other. Complete this. Confirm you have written this down. Comment done. Let me know when this is done. Moving on. Now, the third and the final proportionality is same distance. Same distance. If I say that Ramesh has to travel 120 kilometers for some reason. On day 1, he maintains a speed of 60 kmph. The journey will take 2 hours. He increases the speed to 80 kmph. Speed has been increased. The time becomes 1.5 hours. The time is decreased. Look at the opposite change. Speed goes up, time goes down. Reversal. If he decreases the speed to 40 kmph, I'm saying this is reference. As compared to 60, he is traveling now slower. So he will take 3 hours time. So do you see decrease in the speed translate into increase in time. Increase in speed translates into decrease in time. So here we can say speed and time are inversely related, inversely proportional. So speed 1 upon speed 2 is proportional to, see, speed 1 is above, time will be below, time 1 below, time 2 above. So this is the proportionality ratio, also called as proportion. Hints will be given, speed will be given, time will be given, one value of time will be given, speed will be missing. So you put them in ratio and answer. What are the practical examples of this? Several examples could be framed. If a person has to go from his home to his office daily, he travels faster, time is less, he travels slower, time is more. The simplest possible example is traveling between two places again and again, going and coming back, going and coming back. Distance constant. Simplest possible example. So out of the three proportionalities that you saw, this is the most commonly used in examples, in mock papers, in theory, in books. This is the most commonly used proportionality. In CAT, usually this is the most used proportionality. Same time, equal time is given. That is the most commonly used proportionality in exams. And I've seen people solve questions of this kind, that there is a race track, A starts from here, B starts from here, where will they meet, the 20-second time. Such questions have never been asked in any of the exams. Circular motion, such questions are possible. You are wasting your time on linear motion if you are solving such questions. There's a swimming pool of 10 meters. Ramesh and Rahim start from opposite side. How far they are from the end of Rahim when they meet seventh time? Never asked in any exam anywhere. Second meeting, third meeting is more than enough for linear races. Because circular, there's a pattern. I can ask you 100th meeting, 1000th meeting. We'll talk about that in maybe the 5th lecture of TSD. We might need more than 5 or 6 lectures. There's a lot of content. So what is average speed? Again, there are two variations. I'll cover both. In general language, after this we'll start questions, not to worry. Speed average is simply defined as total distance divided by total time. That's all. That is speed average. Speed average is defined as total distance upon total time. Again, the unit is also kilometer per hour. Unit can be meter per second. Unit is the same as speed. Let me read a small example. Let us say somebody named Mahesh is traveling 300 kilometers in let us say 8 hours. Then later on he travels 200 kilometers, let us say in 10 hours. Then in 10 hours he travels further 150 kilometers in let us say 12 hours. What is the speed average? So as far as the logic goes, all you are supposed to do is add kilometers in the numerator, 300, 200, 150. And in denominator, what do you add? Time, 8 plus 10 plus 12. Total time, denominator, total distance, numerator. So we have 300, 500, 600, 50 divided by 30. Cancel, 60 upon 3. 21.66 kilometers per hour. And it will follow the same logic that you have studied in averages. The division of these two numbers, this is 3 times 24, 60 is 7 times 56, 37.5. This is 20 and this is 8. the average speed will be always between the highest and the lowest value. It will follow all the logic of averages that we have studied earlier in the previous lectures. Speed average in a manner is average. It will be always between the lowest value and the highest value. Now, usually this is not how journeys are broken. In this case, the exact value of distance and time was given. Usually some hints are hidden. Comment done once you write this down. Simple, very simple stuff. Done. Very good. Now, usually they will give you either the hint of distance or they'll give you the hint of time. Rarely both. So how the question will be framed is, somebody named, let us say, Chintu is dividing the distance as d1 and d2, and speeds will be given. He travels d1 at a speed of s1 and s2. Or Chintu might divide the journey if it's a very long journey in d1, d2, d3 at speed s1, s2, s3. So in such cases, you don't try to mug up the formula, but try to create it on the spot. Numerator must be distance. It is given to us. How do you calculate time? Time is equal to distance upon speed. Distance upon speed, d1 by s1 and d2 by s2. This is what speed average will look like. In this case, d1, d2, d3. I can show you questions in CAT 2017, 18, 19 applying these concepts. d1 by s1, d2 by s2, d3 by s3. That is the speed average. Copy this down, comment done, so we can raise the level. Usually only one of the terms will be given, either distance or time, rarely both. Concept of speed average. This is one way of creating a question. Done. Very good. Others also confirm. I've received one confirmation. Others also confirm. All right. Now, a customization of this. Let us say Dinu has divided the journey in two equal partitions of distance. Now I'm using A and B as speed. Speed is A and the speed is B for these two, because S1, S2 confuses people. Or Dinu has divided distances in three parts, three equal parts. That is the catch here. And the speeds are A, B, and C. What will the formula look like? Speed average will look like 2D divided by d by a plus d by b. If I cancel d from both, because d is common, it can be cancelled. This way of writing is called harmonic mean. The speed average is harmonic mean of AB. When you rearrange, it looks a little better. 2AB upon A plus B. I want you to remember this as a formula for speed average only when the distance is same. There are two partitions of equal distances. Here it will look like 3D upon D by A, D by B, D by C. That will translate into 3 by 1 by A, 1 by B, and 1 by C. When you rearrange that, you will have this. So I want you to highlight the speed average formula, and I can show you application of this in recent years paper. I'll just remove myself from the screen. I think I'm hindering some portion of the screen. Yeah, copy these down. Let me know once you have taken these down. It is a customization when the distance is divided in equal parts. Moving on. Now, when, let us say, 𝒊 divides the journey in time intervals. So what happens is, let us say 𝒊 has to go from Pune to Mumbai in 6 hours. So now, because time is the restriction, the journey can be divided into time intervals. Let us say there are two time intervals, time t1 and time t2, and speed will be given. The speed for the first part is s1 and second is s2. So you remember speed average formula is distance total upon time total. You see, time has been given to you directly. Look at this value and look at this value. So out of the two, denominator is available to you, t1 plus t2. How do you calculate distance? Distance is equal to speed into time. So multiply both, s1 t1, s2 t2. That is the formula for speed average. If there are three intervals, not a very big deal, t1, t2, t3, at the speed of s1, s2, and s3. So the formula looks very simple. S1 T1 plus S2 T2 S3 T3 divided by T1 T2 T3. No fancy stuff. Distance must be in the numerator. Distance is equal to speed into time. time must be in the denominator. That is T1 plus T2 plus T3 is the time. Good fundamentals are needed for cracking CAT. So we are covering all fundamental theory first. Now, a customization of this, again, time intervals. But in this case, the time interval is equal. Time t is same. I'm using speed as capital A and capital B. So it will look like speed average is equal to 2t plus A into t, B into t. Speed into time is the distance of the first part. Speed into time is the distance of second part. So t is cancelled out. This way of writing is called arithmetic mean or the general average. Speed average is A plus B upon 2. If there are three partitions, you don't have to write too much. Time is equal. Speeds are A, B, and C. The formula looks like A plus B plus C directly upon 3. That is speed average. No rocket science. Absolute basic. You divide journey in equal time parts, speed becomes the normal average. Now, one very small question, it used to be asked in earlier times interviews of IT companies, something like this. You go from Mumbai to Pune at 100 kmph and Pune to Mumbai, let us say at 50 kmph. What is your average speed? What is your average speed? So because you are going from Mumbai to Pune and Pune to Mumbai, beta, distance is same, not the time. So in this particular case, this used to be asked a long time back in interviews. Your speed average would look like 2 into 100 into 50 upon 150, twice of A into B upon A plus B. Cancelled one times, cancelled three times, cancel three times. That is 200 by 3 is the speed average. Never apply equal time. Can the time be same? You're traveling on the same road with the speed of 50. Earlier you were traveling on the same road with the speed of 100. Can it be same? No, time cannot be same. So two variations. Breakdown in terms of distance, breakdown in terms of time. Copy this down. Let me know it's done. Speed average is general speed. A plus B upon 2, A plus B plus C upon 3. Done. Chalo, moving on from this. Now go on, try this. A very simple question. Give me answer. Type your answers. By walking at 3/4 of his usual speed, Sumit is late by 1.5 hours. What is the usual time taken by him to cover the same distance? So let me form equations first. There can be multiple methods. Earlier speed is x, earlier time is t. This is what Sumit used to travel. Speed into time is equal to distance. Today, the speed has been lowered to 3/4. And because speed was lowered, obviously, if you travel slow, you drive slow, you will take more time to complete the journey. The time is 1.5 hours more. If I rearrange this will be 4x t is equal to 3x t plus 1.5. Notice here, x is cancelled. 4t is equal to 3t. 3 into 1.5, 4.5. Move, t is equal to 4.5 hours. That was the question. What is the usual time taken? Usual time is t. What is the delayed time? What is the new time? 6 hours. You can answer both. You can find both delayed time also and the original time as well. Old or original time. Now this is method 1. Common sense, form equation. Speed into time is equal to distance and distance is same. Now do you remember when distance is same, speed and time are inverse? Please listen to my language. Please try to understand what this means. The original speed was 4, the new speed is 3. This is called 3/4, 4 becoming 3. Now because speed and time are inverse, time old and time new will be opposite. If this is 4 and 3, it will be 3 and 4. What is the gap here? The gap is 1. What is the real gap? The real gap is 1.5 hours. What was the delay? What was the delay between the two times? 3 becomes 4. So extra looks like 1, but the delay is 1.5. So this is called multiplying factor. So multiply 1.5 here. The old time is 4.5 hours and the new time is 6 hours. With practice, I can assure you, you can answer this question verbally. You can perform these calculations mentally. Focus more on method 2 because method 1 is too easy. Good. Moving on. Try this. Take just 1 minute. I can't give you more time. These are very elementary questions. Take 1 minute. Answer. A person crosses 900 meters in 5 minutes. What is his speed in kmph? So I said apply common sense. You don't always have to go for Gisapita concept. 5 minutes. How do you convert 5 minutes into 60 minutes? Because 60 minutes is 1 hour. You multiply it by 12. So you multiply 12 on this side. It becomes 10800 meters. How do you convert meter into a kilometer? Divided by 1000. So 10.8 kmph is the speed. Job done. You want to go along the conventional path. Meters divided by 1000 is kilometer. Minute divided by 60 is 1 hour. So 900 by 1000, denominator into 5, numerator 50, 5 and numerator into 60. 3 zeros gone. That is 54 upon 5, which is 10.8 kilometer per hour. This will any day take more time, more calculation as compared to this. A common sense approach on the left side. How do you convert? How do you convert 5 minutes into 60 multiplied by 12? Multiply 12 here and you have your answer. 10.8 kilometers per hour. I have seen people give answers, incorrect answers for such questions as well. गलतियां होती हैं because TSD same concept, same formula is used multiple times. Mistakes होते हैं. That's okay. A train covers 300 kilometers in 20 hours. If journey time needs to be reduced by 25%, what is the new speed? Journey time needs to be reduced by 25%. What is 25%? 25% is 1 by 4. You want to reduce reduction, so you must multiply 3 by 4. The time was 20 hours. You are decreasing it by 25%. So you are going to complete the journey in 15 hours. What is the speed required? You want to travel 300 kilometers in how much time? 15 hours time. So what speed are you maintaining? 20 kmph. You are maintaining a speed of 20 kmph. On. Try this. Raman walked at a speed of 15 kmph instead of 12 kmph on his daily walk. He would have walked 12 kilometers more in same time. How much does he walk daily? So the most important phrase is same time. Same time. Because time is same, speed represents distance. So you see, form a ratio. Speed ratio is 15 by 12, which is 5 by 4. So distance ratio will also be 5 by 4. How much more do you see? 4 and 5. I see one more. How many kilometers did he actually travel more? 12. 1 must become 12. So this will be 60 and this will be 48. Now he walks daily. Daily he walks this. Today he walks more. So daily answer would be 48 kilometers. Why are these questions created? To help you apply proportions. You want to apply equations, we can do that. Try this. If the difference in time taken to cover a certain distance at 10 kilometers per hour and 12 kilometers per hour is 30 minutes, find the distance in kilometers, usual time in minutes. What does it mean? Usual time in minutes to travel the journey, to complete the distance. And the speed, if I want to save 45 minutes. Right now, how much time is the person able to save? 30 minutes he can save. What if I want to save 45 minutes? There are small 2-3 parts of the question. Let us say Suresh travels the same distance. Normally he travels at 10 kmph. Today he is traveling at 12 kmph. Because of this, he could save. Speed ratio looks like 10 upon 12. Time ratio will be reverse, 12 upon 10. We have talked about this. When the distance is same, speed and time are reverse. So what does the time ratio look like? 6 by 5. What does the gap look like? Gap of 1. What is the actual gap of time? 30 minutes. 1 is equal to 30. So 6 must be equal to 180 minutes. 5 must be equal to 150 minutes. Now think slowly, think carefully. Usual time is the earlier time. Usual time is 180 minutes. What is the distance? Now I want to learn this. This is the speed and immediate below is the time. देखो आपने रेशो को रिवर्स कर दिया ना. So speed के नीचे is the time. What is the speed? Distance is equal to speed into time. Speed is 10 km/h and time is 180 minutes. 180 minutes is what hours? 3 hours. So what is the distance traveled? 30 kilometers. Now see, second part, the answer is 180 minutes. What is the usual time in minutes? 180 minutes. What is the distance traveled? 30 kilometers. Now what is the question? I want to save 45 minutes. Normal journey time is 180 minutes. So if I save 45 minutes, I'm traveling 30 kilometers in 135 minutes. How do you convert minutes into hour? Divide by 60. So what is the speed new? 45 minutes saving wala? 30 into 60 upon 135. जितना हो सके cancel कर लो. This is 15 into 2. This is 15 into 9. 3 into 3. 3 into 20. So 40 upon 3 kmph will be the speed. Take your time, observe. Simple questions. First 10 questions, first 9 questions are like that. I showed you 12 and 10. Time ratio is reversal, 12 and 10. 6 by 5 time. I can see 1 minute being saved in the ratio. In the ratio that looks like 1 minute being saved. In reality, the saving is 30 minutes. So how do you convert 1 into 30? Multiplying it by 30. Confirm this, you're done with this. Once I find out time, then I go and find out distance, and then I go and find out the speed new. "45 minutes were supposed to be saved. Once we have that ratio is 6 by 5, so I can see 1 unit ka saving. 1 unit ka saving. वो 1 unit का saving नहीं है, that is actually a saving of 30 minutes. तो अगर 1 becomes 30, 1 becomes 30, so this will become 180, this will become 150. तो usual time is 180 minutes. 180 मिनट लगते हैं, which is basically 3 hours. अब देखो, this time will show you the speed above. उसके ऊपर ही speed लिखा. So 3 hours with the speed of 10. 3 hours with the speed of 10. So journey is 30 kilometers. What is the distance traveled? 30 kilometers. Or third part, what was the third part? I want there to be 45 minutes का saving. So 180 minutes is the normal time. 45 minutes saving means 135 minutes. So distance upon time is equal to speed. So this third calculation on the lower side of the board is about speed, finding the speed. Moving on from this, shall try this. A man walks at 4 kmph. He misses the train by 5 minutes. If he walks at 5 kmph, he reaches 10 minutes before the arrival time. How far is the train station? So see, it is a comparison being given to you. When he travels slow, he is late. He misses the train. When he travels fast, he is early. So let me solve it through equations first. Can I say the common assumption is the distance is same. Distance is same. So speed into when somebody is late, the person is taking more time than normal. When the speed is high, the person is early before means the person is taking lesser time. These are in minutes. So when I rearrange 40 plus 20, 5t minus 50, transfer it here, t, transfer it here, 70. So normal journey time is 70 minutes. Now you put it here or you put it here makes zero difference. Normal time is 70 minutes. If I put 70 here, 5 into 70 minus 10. This is in minutes. This is in kilometers per hour. देखो, in earlier case, the unit did not matter क्योंकि unit दोनों side will get cancelled. Right now I am calculating distance, so I need to divide it by 60. ये क्योंकि minute को hour में करना पड़ेगा 5 kilometer per hour into 60 upon 60. So 5 kilometer is the distance of train station from person's home or wherever he is walking from. 5 kilometers is the distance from the original place of this particular person. Done. Very good. Very good. Try this. A train travels 300 kilometers at a uniform rate. If the speed of train had been 5 kilometers per hour more, the journey would have taken 2 hours less. What is the speed of train? Now, this question is currently at NMAT level, SNAP level. The earlier three questions are very, very fundamental. In this, you might end up with a awkward equation. What is the train traveling? 300 kilometers. The speed of the train had been 5 kilometer per hour more. अगर speed ज़्यादा होता तो 2 hours less लगता. So we are saying 300 kilometers when traveled on normal speed, it takes some time t. 300 kilometers when traveled on a higher speed, the time taken is 2 hours less. So what I am doing is I am replacing that value here. 300 upon x is equal to 300 upon x plus 5. Calculation error. 300 upon x plus 5 is equal to t. 300 upon x minus 2. So you are supposed to solve this. And if you observe, when I cross multiply with x and x plus 5, this becomes x into 300. This becomes x plus 5 into 300. And this becomes minus 2 into x plus 5. This leads to a quadratic equation. This is 300x. This is 300x plus 1500 minus x square plus 5x. So this is cancelled, this is cancelled. That means 2x square plus 10x minus 1500 is equal to 0. That gives me x square plus 5x minus 750 is equal to 0. ये solve कौन करेगा? Tell me, who will solve this? Why will you solve? This is called a quadratic equation. Why would you solve this? Why do you want to waste your time? So the idea is ये सब नौटंकी नहीं करना एग्जाम में. Once you reach this level, use options. Options nahi given hai, you have to do this. If it is a theta question, you have to do this. Let us say speed is 20. Put 20 here. Put 25 here. 300 upon 25. Let me do this. Option A. 300 upon 25. 300 upon 25 is 12 hours. 300 upon 20 is 15 hours. Does this equation match? Is 12 equal to 15 minus 2? No, it does not. Let me test this. When I put 35 here, क्या 300 divide होता भी है from 35? Is 300 divisible by 35? No. बाद में देखेंगे. Use this value. If I put 25 here, it becomes 30. And this will become 25. 300 by 30 is 10 hours. 300 by 25 is 12 hours. Is this equation matching? For option C, is this equation true? Yes. So once you reach here, you check options. This is the full solution. This is the foolproof solution. But you will need understanding of quadratic equation. A person like me can see that this looks like 25 into 30. अब मेरे को काम करना पड़ेगा नेगेटिव पॉजिटिव कौन सा 25 is positive 30 is negative. This is positive. So this is 25 positive 30 negative. So factorizing a quadratic equation takes time. Once you reach that equation 300 upon x plus 5 300 upon x, there's a 2 hours gap. Moving on. Try this. Thor. Be very careful. Be very careful. Thor walked into woods at a rate of 4 kmph and returned to his starting point at the rate of 3 kmph. If the entire trip took him 3.5 hours, how far did he go into the woods? How far did he travel into the woods? Take a minute. Give me an answer. So now you observe the person named Thor is going into the woods and coming out the same distance. Can I say the speed average will be 2 into 4 into 3 upon 4 plus 3. Don't exactly calculate this, represent, that is more than enough. 2 into 4, 8, 8 into 3, 24 upon 7 is the speed average. How much time did he take? 3.5 hours. Can I say speed average into time? 24 upon 7 into 3.5. Cancelled twice, cancelled 12. So he is traveling a total distance of 12 kilometers. 12 kilometers is jana plus ana. That would mean Thor is traveling 6 kilometers one way. How far into the woods did he go? He traveled 6 kilometers into the woods. So apply common sense here. Yes, you're on the right path. I can see your calculations. You have made one calculation mistake. The speed is 3 kmph. You have used in your calculation 3.5. I can see your rough work. Both are गलत किया आपने. You have done what? Total hours are 3.5. Total hours are 3.5. X upon 3 plus X upon 4. So 3.5 is equal to, the numerator becomes 7x upon 12. So rearrange कर दिया. X is equal to 24. 6x equal to 6. तो 6 किलोमीटर आंसर आ तो रहा है. Moving on. The time taken by 3 sprinters to reach end of a track is 6:4:3. What will be the ratio of the speeds with which they covered the distance? This is what ratio of their time. So try to understand. If I give you ratio of speeds as 2/3, the ratio of time, speed is 3/2, time will be 2/3. It is perfectly fine. दो नंबरों का reverse means reversal of the order. 3 नंबरों में it does not work like that. Listen to this. 3 sprinters reach the end of the track, and this is the time ratio. The time ratio is 6:4:3. Understand, the speed ratio will be 1/6, 1/4, 1/3. In ratio proportion variation, I have taught you how to deal with these. 3 का इनवर्स बेटा 1 होता है, not in this. ये 2 तक ठीक है. You multiply the LCM of denominators. LCM is 12. 12/2, 12/6, 2, 12/4, 3, 12/3, 4. Done. Moving on. The answer is none of these. Try this. A train was able to save 1 hour of journey time. A train was able to save 1 hour of journey time when the speed increased by 20 kilometers per hour over a distance of 600 kilometers. What is the increased speed of the train? This will take a lot of time. If you go for equations. Try 3 minutes. A train was able to save 1 hour of journey time. 1 hour of journey time when the speed was increased by 20 kmph. इसमें टाइम लगेगा आपको, you will need time for this. What are we saying? When these 600 kilometers were traveled on a certain speed, and when these 600 kilometers were traveled on a higher speed of 20 kmph, there was a saving of 1 hour. Read that part. A train is able to save 1 hour of journey time when the speed is increased by 20 kmph over a distance of 60 kilometers. What is the speed of the train? What is the speed of the train? So if you decide to solve this, you cross multiply this, you cross multiply this, you will have 600x plus 12,000 minus 600x upon x into x plus 20 is equal to 1. So this is cancelled, cross multiplying this. 12,000 is equal to x square plus 20x. Rearranging that, you will have x square plus 20x minus 12,000 is equal to 0. Now you have to think a way to now you have to think of a way of solving this. To solve this, you either need to have very good understanding of factorization method or the formula approach. What is the formula for a quadratic equation? The roots a comma b are minus of the middle term plus minus root over square of the middle term 4 into 1 into this. So it will become plus 4800 upon 2. So see, roots cannot be negative, speed cannot be negative. So the speed will be 20 negative plus this is 4848400. That is a square of see 484 is a square of 22. So it's a square of 220 upon 2. So minus 20 plus 220 upon 2 is equal to 100 kmph. तो पहले का speed was 100 kmph. The new speed will be 120 kmph. So on the outset ये दिखने में बड़ा ही आसान सवाल दिख रहा है. So दिखने में सवाल बड़ा इजी है, बट इन टर्म्स ऑफ कैलकुलेशन ये काफी टाइम टेकिंग क्वेश्चन है. मूविंग ऑन, इनसे आगे बढ़ते हैं. A train covers, अच्छा, now if you are good with numbers, अगर आपका numbers strong है, I might be able to suggest another approach here. आपका अगर numbers strong है तो I can probably suggest you one more approach here. आप ना क्या करो, 600 के factors लिख दो. I'm using another slide. 600 क्या क्या चीज से डिवाइड होता है? It is divisible by 1 how many times? 600 times. Divisible by 2 300 times. Divisible by 3, it is divisible 200 times. Divisible by 4, 150 times. Divisible by 5, it is divisible 120 times. Divisible by 6, it is divisible 100 times. Divisible by 7, no. By 8, yes, it is divisible by 8. 8 into 7, 5. By 9, no. By 10, yes. 11, no. 12, yes. 13, 14, 15, is it result 15? Yes. So listen to the language. If this is the time, then this is the speed. If this is the time, this is the speed. This is the time, this is the speed. So a factor on the left side matches the factor on the right side. See, I need in the time, I need a gap of 1. In the speed, I need a gap of 20. Do you see there's a gap of 20 here, and these two are corresponding to these two. There's a gap of 1 here. So 5 hours, speed is 120. 6 hours, the speed is 100. 20 ka gap, that is speed ka gap. 1 hour ka gap, that is time ka gap. So for this kind of thought process to work, you need to think about factors. Confirmation on this? Moving on. Let us try one more question, then we'll call it a day. A train covers a certain distance daily. One day, the speed of the train was increased by 6 kmph, and it managed to reduce the journey time by 4 hours. Another day, it was moving at 4 kmph slower, and it was delayed by 4 hours. What is the distance traveled by train daily? So here try to understand, so far in every question up to this point, the exact speed was given. So you can take a ratio and work with it. What is happening here is the increase in the speed is 6. So the journey time is less by 4 hours. Speed is not known. Speed is not known. Increase is known. Next day, the speed is decreased. So journey time is increased. In such question, there's a formula that we can share with you. Let me try to derive that formula for you. See, again, I'll give you the crux at the end. I'm saying the normal speed is x, normal time is y. Today, the speed is increased by 6, and because of that, time is decreased by 4. Again, normal speed is x, normal time is y. Speed is decreased by 4, and the time is increased by 4. I'm solving the first equation. See, xy is equal to xy plus 6y minus 4x minus 24, xy plus 4x minus 4y minus 16. Do you see xy cancelled in both? It gives me a linear equation. What is that equation? 6y minus 4x. 6y minus 4x is equal to 24, and here it is 4x minus 4y is equal to 16. You notice here, just by adding the two, I can have 2y is equal to 40, x is equal to 20, x is equal to 20, y is equal to 20, y is equal to 20. And if I put y is equal to 20 anywhere, let us say in this one or in this one, if I put here 20, so this becomes 80, this becomes 96. 4x minus 4 into 20 is equal to 16. 4x is equal to 96, x is equal to 24. So I know the speed, I know the time, the total distance is speed into time. So 480 kilometers is the distance. Now, what is this formula I was talking to you about? What is the change in the speed? 6. You multiply 6 positive with the time. What is the decrease in the time? 4. You multiply negative that with the speed. And the total value is multiplication of both. Do you see the exact same equation here? 6 into time minus 4 into speed is equal to 24. Listen to the language carefully. What is this? Decrease in the speed. Decrease. So negative 4 you multiply with the time. What is this? Increase in the time. Increase you multiply positive with speed. And multiply both without a sign. 4 into 4, 16. So do you see these equations that I'm applying here are the same equations I got here. But to get these, I had to write 4 to 5 lines of calculations. What is the idea? You multiply the change in speed with time and change in time with speed to form a linear equation. You're basically creating deviation here. Moving on, guys. You want to repeat any part of this? In this case, I have assumed y is equal to time. In this case, yes. And x is equal to speed. Done? Very good. So tomorrow we'll continue with these questions. In the next lecture, after that, we'll see relative speed. Then we'll see a session on races, linear circular. And at the end, we'll see escalators and traveling on rivers, moving water. You'll see today also in the morning, I've shared maybe 6 good questions in the common group. Give it a try. Group mein, whenever I share a question, take some time out, give it a try. You're not able to solve, post in the paid group. Yeah. Good night, guys.